Hi, folks. Matt here with BayWa. We're just going to give everyone a couple more minutes. I see everybody's still logging in, so just another 2-3 minutes, and we'll start the webinar. Thanks so much. Hi, folks. Matthew Lanigan here again with BayWa. I'm the Chief Commercial Officer. Just like to thank you all taking the time out of your busy day to spend a little bit of time with us and learn about Sol-Ark. Just a couple of housekeeping notes. If you have any questions, we'll do the best we can to answer them in real time. You'll notice there's a chat box down in the bottom corner for questions. So just type them in there and we'll answer them best we can. If we don't get to them all, we'll be sure to answer them during breaks or towards the end. This will be recorded and you can ask your rep for it after this has happened, and or we put them out monthly with our monthly newsletter. Continuing education is really important to BayWa. It's a principle we like to adhere by, so we really appreciate you taking the time to learn with us. I would like to introduce our friends from Sol-Ark. David Parker with us, who's Sales Business Development, and we also have Dustin Douglas, Technical Sales Manager. So without further ado, I'd like to hand it over to Sol-Ark.
Yeah, thank you very much. We appreciate that, Matt, and thank you very much to everybody at BayWa. We appreciate this opportunity. Let me do that. All right, is that looking good for everybody?
Yeah.
Okay, awesome. Well, again, thank you very much to BayWa. We are Team Sol-Ark. My name is David Parker, and I'm joined by my colleague Dustin Douglas. And without any further ado, let's jump into the Sol-Ark solution. So if you were to design a fantasy hybrid inverter, if you literally took a blank piece of paper and said, okay, I'm going to design the world's best hybrid inverter, what do I want this inverter to do? What do I want it to be capable of? What features do I want it to have? So first off, if you're an installer, you would want this to be able to make you look like a hero by being able to say yes to a wide variety of applications. You would want this inverter to work fantastic in a grid-tied fashion. You'd want it to have complete functionality off-grid, and you would want it to be able to transfer blazingly fast if the grid ever dropped. You would want the inverter to be able to AC couple to existing systems that have inverters already. You would want it to DC couple to new systems and bring the PV directly into the inverter itself. And perhaps you would want to AC couple and DC couple at the same time. You would want this inverter to be able to back up a whole home. You would also want it to be able to work off-grid, where the inverter and the energy system was the power source for the home 24/7, 365. You would want this inverter to be able to talk to generators, auto start the generator, and charge a battery with the generator. You would want this inverter to limit your truck rolls with easy, efficient, very intuitive setup. You'd want it to have a 10-year warranty, an ultra reliable military grade design. You would want this inverter to have a company behind it that had your back literally and answered their phone 7 days a week live in person in case you called and needed something. You would lastly want this inverter to have a monitoring solution that not only provided you visibility and not only provided you access, but also provided you complete remote control. If you are an installer and you're listening, I just said Sol-Ark will save you money. The monitoring solution has complete remote control in addition to access and visibility. The good news is we are the fantasy inverter. Everything on this slide is Sol-Ark. This is our list of capabilities. We're out in front, and this is what we do. And we literally have your back. We answer our phone 7 days a week. And lastly, that monitoring solution I mentioned also has a fleet management function if you are an installer. So if you're an installer and you install one system and then 5 systems and then 20 systems, you can go into Power View, which is what we call it. You'll see that later. You can go into Power View under your installer banner and see all 20 systems. Again, complete access, complete visibility, and complete remote control. That's Sol-Ark. So versatility. Let's talk about versatility. And let's talk about it in the context of today's supply chain. We were having this conversation earlier, and this slide took on a little new meaning. The supply chains are a little wonky out there these days. There's a shortage of sea containers. There's a shortage of this. There's a bunch of ships lined up in in Long Beach and California and the customs, and you keep hearing about this stuff. The versatility of Sol-Ark is a strength. We can use any solar panels with our inverter. 60 cell, 72 cell, Longees, Trinas, Hanwha Q cells, Mission Solar from Texas. We don't care. REC Solar, Canadian Solar, great panels, all of them awesome. You can use any of them with our inverter. The battery, you can use any battery with our inverter. We are agnostic to the battery. We require a 48 volt solution, but having said that, we don't care about the brand, we don't care about the type, and we don't care about the chemistry. So lead acid batteries, AGM batteries, gel batteries, lithium ion batteries, lithium ferrophosphate batteries, don't care. 48 volts. Move over to the generators. Same thing. You got a little generator with the wheels and a handle. You throw it in the back of your pickup truck, take it camping with you in the RV. Great. You got a big generator that sits on a 6 or 8 inch concrete pad next to your house. It's 30 kilowatts. Great. You got a Kohler, you got a Century Pro, you got a Generac, you got a Briggs & Stratton, you got a Honda, you got one of those ones nobody's ever heard of you bought off a Harbor Freight. Don't care. It needs to be a 208 or 240 volt generator, and it works with the Sol-Ark. Maximum versatility. We heard the supply chains all whack on generators. Hard to get those these days. The batteries, every battery manufacturer is very carefully watching their supply chain. Same with the solar panels. What customers want is integration. They want all of these assets to work for them. So you have the Sol-Ark here, you got a solar system, you got the batteries, you got the generator, you got the grid. If the grid is up, the Sol-Ark has a number of modes to interact with the grid and save you money or make you money. We can sell power to the grid, that'll make you money. If your local utility has a VPP program, which stands for Virtual Power Plant, we can enable those communication signals via IEEE 2030.5 and OpenADR 2.0, et cetera. We can make you money by letting you participate actively in the energy markets. That's kind of a new and exciting trend. We can save you money if you have a time of use rate structure. We can save you money every day. If you have KW demand as part of your rate structure, we can save you money every day. So if the grid is there, the Sol-Ark has the intelligence to use all of these assets for your benefit and save you money and make you money and interact with the grid. If the grid goes away, in 4 milliseconds, you're off grid and you continue to use all of the assets connected to the Sol-Ark for your benefit. Grid's down, you've got your solar system, you've got your batteries, you've got your generator, you are up and running. The Sol-Ark is the micro grid brains in this system, and what people want is maximum versatility and maximum functionality for their behalf. So we have 3 inverter models. We have a 5K, an 8K, and a 12K. First and foremost, the 5K and the 8K are single unit only solutions. So they don't parallel, they don't stack. You can't make 2 5Ks, you can't make a 5K with an 8K, you can't make either the 5K or the 8K with the 12K. They're single unit only solutions. Both the 5K and the 8K inverters come standard with a 5-year warranty. That is upgradable to a 10-year period. The 12K inverter comes standard with a 10-year warranty and is stackable. It's highly stackable. On our 12K inverter, you can stack up to 8 of them in a 120 240 volt context, and you can stack up to 9 of them in a 208 volt 3-phase context. We'll talk about the voltages in a minute. We do have multiple grid frequencies and voltages available through our inverters. Any one of the 3 versions that we have, the 5K, the 8K, or the 12K, can come in an EMP hardened version. We'll talk about that in just a second. EMP stands for electromagnetic pulse. But lastly, let me not forget, everything we ship is in a NEMA 3R outdoor rated enclosure. We have no, they can be used indoor for sure, not a problem at all. So they're indoor, outdoor, they are NEMA 3R, but we don't have any indoor only solutions. Everything we ship is NEMA 3R. So what comes in the box? If you order an inverter from Sol-Ark and you get it through BayWa, which is where you want to get it from, everything you see comes in the box with the exception of B and C. That top row right there in that white box, those are 3 different sizes of CT limit sensors. What comes in the box with the inverter is A, and A is a pair of 100 amp 5/8 inch CTs. B and C, B is 15/16, and that's going to be a 200 amp CT, and C is 2 inches, and that's going to be a 400 amp CT. What comes in the box is A, and that's a pair of 100 amp CTs, 5/8 of an inch. Everything else you see comes in the box. D is the battery temperature sensor cable with the thermocoupler there at the end. E is a pair of the battery cable toroids. We'll see those in a couple slides on how to use those. F is the parallel cable. If you want to have the Sol-Arks talk to each other, you want to stack them. That's the Cat5 cable. That's how they communicate. G is the little wrench there in case you need to open the top. H is the French cleat. That metal bar right there is how you're going to mount the Sol-Ark onto the wall. Very, very easy. I is the dongle. The dongle is both Cat5 and Cat6 capable if you want to use a cabled solution with Ethernet cable. It's also Wi-Fi capable. And then, of course, the inverter and the manual come in the box as well. So this is a shot of the home screen. This is the default screen that the user is going to see when the Sol-Ark is up and running. It's meant to give them a snapshot of what's currently going on, as well as providing them a lot of information. So let's take a look at this. You can see there's a little box at the top that says solar today and solar total. The solar today, of course, is going to be the solar production since midnight of the current day. The total, of course, going to be the solar amount of PV power coming in since installation. Below that, you'll see 4 icons. There's a PV panel for your PV system. There's a transmission tower, represents the grid. The light bulb represents the load of the home. The battery, of course, represents your energy storage. Underneath that, you see some numbers. Everything's in kilowatts. Got kind of a tachometer looking situation down there. So under the solar panel, of course, going to be the solar power production. Under the transmission tower for the grid, it's going to be what is currently going on with the grid. If that number is negative, you're selling power to the grid. If it's positive, you're getting power from the grid. The next one is the load. That's going to give you the information of the current load that's going on, the consumption of the home. And then the one after that under the battery is going to be what's going on with the batteries. Again, there's a positive, negative impact there. If that number is negative, you're charging the batteries. And if it is positive, you're discharging from the batteries. So let's take a quick look at the story that this is telling us, because this screen does tell you a story. The solar system is making 12 kilowatts right now. That's a good size solar system. Must be a sunny day in Texas or a sunny day in Texas North. And we're making 12 kilowatts. Bounce over 2 under the light bulb, and you see the load or the home is consuming 5 kilowatts. So the Sol-Ark said, all right, I got 12 kilowatts of DC power coming in. I'm going to convert that to AC. I'm going to put 5 kilowatts over here to the home. I'm going to convert some more power to AC, and I'm going to sell power to the grid. So it is selling power to the grid right now, 4.6 kW. Oh, and as long as I have all this extra power, I'm going to go ahead and charge the batteries as well. So what you see in this snapshot is 12 kW coming off the PV, 5 kW being used by the home, and you are simultaneously selling power to the grid and charging the batteries while servicing the loads. If you put your finger on these icons, they do things, right? So it's a touch screen. So if you touch the PV panel, you're going to open what we call the PV Graphical View, and it's going to give you some graphical information. You can set, week, day, month kind of thing, and show you what the PV system's doing. If you put your finger on the transmission tower, it's going to open a similar view for the grid, and it'll tell you all about the grid, and it'll have a graphical representation of that as well. If you put your finger on the light bulb for a few seconds, you're going to force smart load. We will talk about that a little deeper in the presentation here. And then if you put your finger on the battery, you're going to open what we call the detailed volts view. Just gives you some good information all in electrical terms as far as what's going on with all the different assets. That's a very useful view for the technical support team. And then the settings is the sprocket. So if you put your finger on the sprocket there where it says settings, you're going to open the subsequent menus to set up the Sol-Ark. When you buy a Sol-Ark and an installer wants to set it up at somebody's home, there are 3 phases to it. It's very simple, and there are 3 phases to it. The first one is mounting the Sol-Ark, and you literally hang it on the wall, put the bolts in the side. Couldn't be easier. The second one is wiring. You wire up the Sol-Ark. We're going to see more about that in just a second. That's phase 2. First one's mounting, second one's wiring, and then the third one is the setup. Well, the good news is the setup is done with your fingertip. You literally put your finger on the settings button. It opens up all the menus. You select things with your fingers, manipulate it with your finger, click OK, and you set it up. There's a basic setup, a battery setup, and a grid setup, and then you're done. Super easy. And we'll see all that as we continue here. In our manual, in all of our manuals, we like to be as proactive as possible. So this is a very simple component distance guide. It's a wire run length guide. We get asked a lot of questions. How far can my panels be from the inverter? How far can my inverter be from the panel? How far can the batteries be from the inverter? Etc. So this is included in the manual. It's on page 43. It's just a wire run length guide. Same thing here. This is a wire gauge guide. Again, we get asked a lot of questions. How big does this wire need to be? How big does the battery wire need to be? Et cetera, et cetera. So this is in the manual. You can see the CTs up there. The 100 amp CTs, that's 5/8 inch, that comes in the box. And then the bigger CTs, those 2 CTs, if you need to either get the 1-inch CT or the 2-inch CTs, other than rapid shutdown, those are really the only extraneous little electrical things you might need to do a Sol-Ark installation. The Sol-Ark is very, very integrated. A lot of breakers, a lot of disconnects, transfer switches, everything's built into the Sol-Ark. So it's truly an all-in-one inverter. But we like to include all these things in the manual to be as proactive as we can when it comes to helping homeowners and installers, deploy our solution. Same thing with this. When it comes to stringing solar panels to the Sol-Ark inverter, again, there's 2 ways to connect. You can AC couple or DC couple. If you AC couple, you're literally bringing in AC power from an inverter that has a solar system already. Might be a Fronius, might be in-phase microinverters, could be an SMA, might be a SolarEdge. We AC couple to those systems and those inverters all the time. So that's one way to do it. If you're going to run the PV directly into the inverter, let's say it's a new construction, new installation where they don't have an inverter already, then you would be crazy to buy 2 inverters. You don't need them. Just bring the PV directly into the Sol-Ark. Well, when you do that, we have 2 Mppt controllers, and there are 2 strings of solar each. So you can bring in 4 strings of solar into the Sol-Ark. What we watch for when you're stringing is voltage open circuit temperature corrected. What you want to do is stay below 500. 500 VOC temperature corrected is the limit. At 550 VOC temperature corrected, damage will occur to the Sol-Ark. And really, we like it to be closer to, say, 450 would be the optimal spot to land on. The good news is it works like this. Let's say you have a Hanwha Q-cell panel and it's 360 watts. And you pull up the data sheet and it says VOC 42.5. So it's got 42.5 volts open circuit. Well, you're thinking to yourself, I want to use 10 of these in a string, right? So for what I say the panels were 360, you'd have to do the math, 3.6 kilowatts, et cetera. So you look at the 42.5 voltage open circuit, you want to use 10 panels, 42.5 times 10 is now 425. That's great. Then you come to this tool right here. And this tool right here is for the temperature correction part. It's a string temperature compensation. This tool is on our website. It's for installers or homeowners that maybe perhaps are going to do their own system. You literally enter these inputs from the data sheet of the panel, and you go over to the strings and manipulate the strings. I want to use 8, I want to use 7, I want to use 9, I want to use 10, whatever it is. And then the output down at the bottom will tell you if it's okay or not from a stringing perspective. You can see there's 2 columns there, the yes and the no. The reason MPPT was no is because when you come to the VOC, you've got 530.45 volts open circuit. So that's going to violate the 500. Again, you know, the voltage open circuit is a stringing concern for any inverter. It's kind of, you have to watch something. We have 3 things: 500 volts open circuit for your panels when you're stringing them, 48 volt for your battery, and either a 240 or 208 volt generator. You know, those are the basic electrical requirements. But other than that, you can use any battery solution, any inverter solution, and any solar panel solution. This particular tool is on our website, and it's to help installers with stringing solar panels to our inverter. This is the wiring area opened up at the bottom of the Sol-Ark. So again, I mentioned the Sol-Ark inverters can handle 2 grid frequencies. We can do 60 hertz grids and 50 hertz grids. That opens up a good portion of the planet Earth. Those are the 2 predominant grid frequencies: 60 hertz, 50 hertz, 60 hertz here in North America. Thank you, Mr. Edison. And so we can handle both of those grid frequencies. From a voltage perspective, in terms of service voltages, we can do 220 volt single phase. We can do 120, 240 volt split phase, the predominant residential voltage, and we can do 120, 208 volt 3 phase. And we'll talk about that more in a minute. The 120, 208 volt 3 phase really opens up some commercial possibilities for us. But the important thing to note is there are not different SKU numbers for this. If you have a 12K inverter, you can do 50 hertz grid, 60 hertz grid, 220 single, 120, 240 split, or 208 volt 3 phase. It's the same inverter, right? We don't have a bunch of SKUs. You don't have to figure out which frequency it is, none of that stuff. These are settings in the inverters. You can AC couple. This is our 12K. So this is a Sol-Ark 12K statement. You can AC couple up to 9.6 kilowatts of solar directly from an existing system and directly from an existing solar inverter. You can bring up to 13 kilowatts of DC PV directly into the Sol-Ark. And again, we have 2 Mppt controllers with 2 strings each. So right above where it says 13 kilowatts, those 8 white toggle switches are the solar PV inputs. In the upper left corner, above the battery terminals, you can see a 250 amp battery breaker that's built in. And in the opposite side in the corner, for the grid, the generator, and the load, we have 63, 50, and 63 amp breakers built in respectively. Here is a nice shot of the inverter as it's been installed. You can see that it's mounted on the wall. All the knockouts are done at the bottom. The conduit's brought in. It's got some nice compression fittings there. The battery terminals are connected. The PV wires all populated. The little rainbow colored wires going into the pinouts there, those are going to be sensors and communication. So that's where we're going to land the generator auto start. That's where we're going to bring in rapid shutdown, etc. So that's where that is. You can see the grid breakers populated, the load breakers populated. This is kind of a nice shot of the installed unit. If you notice the motherboard there in the middle, the Sol-Ark inverters have CAN bus, Modbus, and RS485. With those 3 communication protocols, we can talk to generators, we can talk to battery management systems. We'll talk more about that. We have full communications established with a number of popular battery manufacturers, and we can talk to Sol-Arks if we want to start stacking them. So this is a wiring diagram. This is a standard wiring diagram. It's just kind of a very basic setup. It does include batteries. It does include solar. It does include a generator. It does have a critical loads panel, and it does have the CTs. Dustin, you may want to walk us through this real quick, just kind of give us an overview of the wiring diagram.
Absolutely. So this is a very standard 12240 kind of setup. So it does kind of break down into a critical loads panel. You have your generator connections, just as David was talking about. Just keep in mind as you are making your interconnections or connecting to any type of main service panel, make sure to follow. I mean, obviously there's different rules and regulations, but a lot of the times the previous models were 50 amp breakers for the grid and load. Those have been, extended up to 63 amps. So 60 amp breaker, I mean, if my calculations still serve me correctly, won't be able to fit inside a 200 amp panel without derating or any of that nature. But nevertheless, we do recommend a 60 amp for there, and then the critical loads panel and generator connections are pretty standard. Then again, in the middle section, you have your MPPTs for the panels and your battery connections on the left.
Yeah, thank you, Dustin. So the MPPT controllers are right. I don't know if you can see the mouse, but they're brought right into the toggle there. The battery's on the left. And all the blue wires coming in, you can see the battery temperature sensor cable. You can see the rapid shutdown, the 2-wire start from the generator. All of those are landing right here in the pinout area.
And one thing I did want to point out too about the battery communications, especially when it comes to temperature, if you are using a battery that does have closed loop communications, all this information will be presented. So for instance, you don't necessarily have to install a battery temp sensor with lithium. And then especially if you have closed loop communications, then it does provide a lot of great information. So just to kind of throw in a little bit of information.
Yeah, thank you, Dustin. And we'll talk about the batteries here in just a moment. So we did mention that we have the ability to AC couple to existing systems, and that's kind of a, it's a flexibility statement. It's a retrofit statement. If somebody's got 9 kilowatts of solar, or 9.6 kilowatts of solar, and they have a Solar Edge or a Fronius or an SMA, and they want to add battery backup, they can hang a Sol-Ark next to the other inverter, AC couple, connect the batteries, boom, they're in business. Super easy. And that's a flexibility, kind of a versatility statement on our side. If you don't have an existing solar system and you don't have an existing inverter, then you don't need to AC couple at all. You just get your solar system and figure out whether it's roof mounted or ground mounted or however you want to design it, bring that PV directly into the Sol-Ark. The maximum amount of PV that you can bring into the Sol-Ark from DC, straight from the photovoltaic system, is 13 kilowatts. The maximum amount, and this is a Sol-Ark 12K statement again. The maximum amount that you can bring in AC is 9.6 kilowatts. Now, you can do both at the same time. The limit there, let's say you bring in 13 kilowatts of DC, you could also have 3 kilowatts of AC coming in for 16 kilowatts total. And the factor there, as the last bullet shows, is just the 80% rule of the 63 amp grid breaker, which is going to settle you back down to 12,000 watts. But you can AC couple and DC couple at the same time. The max is up to the 16 kilowatts as shown here. This is a note about if you are going to AC couple and there's micro inverters, then this is a note that's about that. So there's a couple different ways to do it. You can use the generator input breaker as the micro inverter input or the AC coupled input. Oh, back up. Or you can use the load breaker. Either way, you're going to want to go into the battery setup menu, and I apologize, but we're going to see all the menus moving forward. This is the menu from our setup. It's in one of the battery setups. The tab is called the Smart Load tab, and right there is a checkbox that says for microinverter input. We've actually changed that now. It says AC coupled input, so this is an AC coupling statement. So if you use the generator input breaker, you want to go to the Smart Load tab of the battery setup, and you want to check right there in the corner where it says AC coupled input. Again, there are some rules here about AC and DC coupling. It's best if they're apart from each other. Low on the AC side or DC side, it's worse or it's less optimal if the two are sitting next to each other, like 5 kilowatts AC, 6 kilowatts DC, or vice versa. It likes them to be one low, one high. The best would be 13 kilowatts DC, 3 kilowatts AC, as it kind of talks about here. The other way to connect, if you're going to AC couple inverters, is to use the load breaker. So when you're wiring this up in the Sol-Ark, you can use the generator input breaker and land it there, or you can use the load breaker and land it there. Either way, you want to go check this for microinverter input, which now says AC coupled input on the smart load. And then if you're going to use the load breaker, even though the generator breaker is not being used, connecting AC coupling onto the load breaker will prevent the use of the generator breaker. Not to worry here. In our manuals, there are a number of wiring diagrams. You've probably heard me say a couple times already in this presentation that the Sol-Ark inverter is very versatile, it's very flexible, it enables you to say yes to a lot of different application types. Well, true statement. So given that, when we went back to our manual, we have about 7 different wiring diagram examples. And there is a wiring diagram example exactly for this slide, exactly for this second bullet here. And in the manual, it says load side AC coupling example. And that's what it's titled for the wiring diagram. It'll show you exactly how to do this. There are about 7 other wiring diagrams. Because, you know, you want to use a little generator? Yes. You want to use a big generator? Yes. You want to AC couple? Yes. You want to DC couple? Yes. You want to AC couple and DC couple together? Yes. You want to do 208 volt 3-phase? Yes. You want to do 120 240? Yes. You want to stack the Sol-Arks? Yes. So we really do enable yes in a lot of different circumstances. The last note here is that when you are AC coupling, you have to go to the smart load and check the AC coupling box there. But when we do that, then the smart load on and smart load off are going to slightly change, right? So now the smart load off is going to be the state of charge at which the AC coupled inverters are shut down when in off-grid mode. And then the smart load on is going to be the state of charge at which the AC coupled inverters are turned on when in off-grid mode. So for AC coupling, the smart load on and off is now going to refer back to the AC coupled inverters. The last note here, super important about AC coupling. When on grid, the AC coupled inverter will always be on and the power it produces will always be sold back to the grid. Limited to home mode will not function with AC coupled PV arrays. So this is very specific, and this is in the manual. This page is straight out of the manual, so everything you see here kind of correlates back to our manual, but it's very specific about AC coupling. So we mentioned batteries, and we mentioned the fact that we are battery agnostic. We don't care about the brand, we don't care about the type, we don't care about the chemistry. We just need a 48 volt solution. Now, having said that, you know, AGM and lead acid batteries, they don't have a BMS. It's just a battery and you hook up to a positive and negative terminal and boom, there you go. Lithium ion, lithium ferrophosphate, they have cells, they're in a nice case, they have a battery management system that regulates everything, equalization, et cetera, et cetera. So the Sol-Ark, we are agnostic to batteries. So any 48 volt battery will work with our inverter. We don't care about the brand, the type, or the chemistry. But having said that, we get paired up with a lot of the lithium ferrophosphate batteries frequently. Stores is an example. Simplify is an example. Fortress is an example. Blue Ion is an example. And so with these batteries, we have partnered up with them. They get an inverter, we get a battery, we put their battery in our lab, they put our inverter in their lab, and we start talking about Modbus addresses and CAN bus addresses and so forth. And what we do is we establish what we call full communications with their battery management system. And what that does is the Sol-Ark then interfaces with their battery management system and lets the BMS govern the battery, which it's specifically designed to do. And then the BMS and the Sol-Ark kind of do the handshake, API to where they can talk to each other. The Sol-Ark gets all the information it needs from the BMS while allowing the BMS to do its job and run the battery. Dustin, anything I left out there in terms of the BMS and full comms?
No, absolutely. I mean, you touched everything on that I would probably hint on. It really is, and we are adding a lot of different batteries every day. I mean, we do work with a lot of different manufacturers, and we do list them on our website. So if you're ever curious, just let us know. We can definitely help you out and point you in the right direction to meet your needs for your project.
Yeah, thank you for mentioning that, Dustin. This is a partial list of the batteries we have full comms with, and there's another half dozen batteries in the building next to me with the lab that we're working on right now to establish comms with. So definitely an evolving subject where batteries come out, they get popular, they start to get some market share, we get mated up with Sol-Arks, we start to hear about it, we contact that battery manufacturer and we'd like to partner up and do that. So as Dustin just mentioned, this is an ongoing effort. We add new batteries all the time. Here's a shot of our batteries. Our batteries are an AGM battery. We call them PCC 230s. PCC stands for partially charged carbon. So it's a thick carbon plate battery. Again, it's an AGM battery, which AGM stands for absorbent glass mat. It's a big, dumb, heavy battery. It doesn't have any BMS. It's just got the case. It's got the carbon plates in there, the electrolyte chemicals, and the positive and negative terminal on the front. So these are the batteries that we sell with our EMP system. We'll talk more about that moving forward. As you can see on the left side with the gray batteries, that's a half rack. And on the right side with the black batteries, those are called a full rack. The way these batteries work is they are 12 volts. So it's a 12 volt, 230 amp hour AGM battery. So we require a 48 volt solution. So we take these batteries in groups of 4 and we connect them in series. So when you connect the batteries in series, your voltage is going to climb 1, 2, 3, 4. I connect them. I go from 12 volts to 48 volts. Then we sell these batteries in groups of 4, which are all 48 volt banks, and we connect those groups in parallel to increase the capacity. So what you see on the left side is 2 groups of 4. The 2 batteries of 4 are connected in series to get to 48 volts, and the 2 groups of 4 are paralleled to increase capacity. Same thing with the 4. Again, 4 groups of 4 in series to get to 48 volts, and then those 4 groups are connected in parallel. Mentioned before that there are battery cable toroids in the box, and that's right here. I don't know if you can see my mouse, but it's the 2 black donut looking things. And what they do is a lot of people see those and go, wow, I've got 2 cable toroids, donut 1 and donut 2, and I've got a red wire and a black wire for my batteries, positive and negative. So I'll put one of the wires through one of the toroids. That's not what you want to do. You want to keep the 2 toroids together, both of them, and put both of the wires through both of the toroids, as shown right there in figure A. And the other thing I would mention is over here, where you have the big yellow triangle with the black exclamation point in it, trying to visually draw your attention to that. This is something that's very serious. When you are connecting batteries to the Sol-Ark, pay careful attention to your terminal, your polarity. Don't connect the red wire to the black one, and don't connect the black one to the red one. If you reverse polarity and you're hooking up the positive to the negative and the negative to the positive, it will damage the Sol-Ark. So very, very serious. Please pay careful attention to the polarity of the battery cables when you are connecting the battery. Generators. We mentioned that we can talk to generators. We require a 208 volt or 240 volt generator. So again, we have basic electrical requirements, and then after that, we're very, very versatile and really open-ended. And again, I mentioned before, from a supply chain standpoint, with our inverter, if you can't get panel A, use panel B. If you can't get panel B, use panel C. You can use any panel. Same thing on the batteries. If you can't get the battery, your favorite battery, get your second favorite battery. If you can't get the second favorite battery, use a new battery. I mean, the fact that we can use any battery, any solar panels, and any generator in today's wonky supply chain world is an advantage and a strength. We have a 7 to 10 day lead time here in Parker, Texas. You place an order for 100 inverters, we'll ship them to you next week. So we're good to go as far as delivering our product into the market. And as far as your ability to get your hands on panels to use, get your hands on batteries to use, and get your hands on generators to use, we try to empower you to use the best choice for your application. If your brother owns a panel company, use those panels. If your cousin owns a battery company, use his batteries. We want to leave you in the driver's seat in terms of what materials you bolt up with the Sol-Ark, and we want to be maximum versatility and maximum flexibility. So bringing that all full circle to the generators, we can handle the little generators. If they're these little portable guys, you're going to want to get a 2-wire start kit. The way that the Sol-Ark will talk to these generators and start them is a 2-wire start kit. These little guys typically don't have 2-wire start built into them. So there is a commercially available kit. You can get it at Grainger, Harbor Freight, whatever, all kinds of places. It's called a 2-wire start kit. So that's how we're going to talk to these little guys. The bigger guys, the whole home backup generators, 10 kilowatts, 15 kilowatts, 20 kilowatts, etc. These are going to be the Century Pros, the Generacs, the Briggs & Stratton, the Kohlers. They will have a 2-wire start. Depending on which manufacturer, it's either included or maybe it's an accessory. Either way, there's going to be a 2-wire start available. Again, that's how the Sol-Ark is going to start these guys, is the 2-wire start kit. But having said that, whether you have the little ones or the big ones, 208 volt, 240 volt, the Sol-Ark can handle it. So this is a wiring diagram that has an example of a whole home generator. So this is a larger generator, and it also has, as you can see, it's got a bypass transfer switch right here in the design as well. And I'll let Dustin, you may want to go over this for us real briefly.
Absolutely. So this does go over a very generic whole home kind of backup situation. Obviously, if a customer is looking at adding solar and they already have a whole home transfer switch, there's no reason to remove that transfer switch, as we can leave it where it's at, and then we can kind of take advantage of it in the Sol-Ark whenever it's available, whenever the grid fails. So in this case, we still have the gen breaker open, so you can actually turn that into a smart load, land AC coupling or on it, or really just use it for, different kind of points of connection. Obviously, everything else is pretty standard as well, with the critical loads panel that would be powered up. So in this case, what would happen when the grid fails is that generator would turn on either by the transfer switch itself or by the 2-wire start if available. So if you want to allow the batteries to be used in an off-grid situation, we can have the 2-wire start be turned on once they're depleted to a specific level that you program. Once the generator turns on, that will allow the customer to take full advantage of the whole home at that point, and then we will use that power to support the critical loads and then even help charge the batteries.
Awesome. Thank you, sir.
Yes, sir.
Oh, that's moving that. That's weird. All right. So EMP, we mentioned EMP before, and we're the only inverter manufacturer that we're aware of in the world that does EMP hardening. Definitely ties back to our military heritage. Most of the people here are former military. The founders are engineers and former military, et cetera. So there are a lot of military folks here. EMP stands for electromagnetic pulse. For lack of a deep technical definition, an electromagnetic pulse is a wave of energy that can be disruptive to electronics. Just to be forthright, I think the two most common scenarios that might have an EMP event here in 2021 in the modern era, one would be some kind of act of aggression, some kind of active war type thing. One country can generate an EMP and target another country, so that is a possibility. I think a more probable possibility is the sun. The sun is a giant thermonuclear ball that's 1.3 million times the size of Earth. Let me say that again. It's 1.3 million times the size of Earth, and it can throw energy at the Earth in the form of an electromagnetic pulse. So any one of our inverters, the 5K and the 12K and the 8K, can have an EMP. I need to update this slide to add the 5K. The SKUs are super easy. You either have an SA8K or an SA-EMP8K. You either have an SA12K or an SA-EMP12K. Super simple. So when you order an EMP hardened inverter, number one, it happens at the manufacturing process. So it's not a kit. It's not an aftermarket thing. I can't email you an EMP kit or mail you an EMP kit for an inverter that you bought last year. Doesn't work that way. It either is or is not an EMP hardened inverter. And it happens that way in the manufacturing process. When you order one, it comes with three things. The kit comes with the inverter itself, which is EMP hardened, and then it comes with 2 sets of ferrite suppressors. We're going to see those in the next slide. There are 40 of the ferrite suppressors that are for the PV panels, so you can have up to 40 panels in your array, and there are 40 ferrite suppressors go on the back of the PV panels. It also comes with 20 ferrite suppressors that are for appliances in the home. Very easy. The ferrite suppressor clamps onto the power cord of the appliance. Again, we'll see that in the next slide. Super easy. So the kit from Sol-Ark for EMP hardening is the inverter and the 2 sets of ferrite suppressors. If a customer desires battery backup in the context of EMP, we recommend lead acid or AGM. And the reason we recommend lead acid or AGM, I touched on earlier, is just because there's nothing there that's going to be susceptible to an EMP. You've got the plastic case, you've got the lead or the carbon plates in the battery, you got the electrolyte solution, you got a cap on the top of the battery, and you have a positive and negative terminal. That's it. What's going to be susceptible to an EMP in the battery world is going to be the battery management system, the motherboard on top of the battery that's running the BMS and has all that circuitry, etc. So again, the EMP kit from us is a protected inverter, either 5K, 8K, or 12K, and then the 2 sets of Ferrite suppressors. If somebody wants batteries in the context of EMP, tell them to stick with AGM or lead acid. Our PCC 230 batteries are an example of that. And so that's what we recommend for the batteries. The Ferrite suppressors look like this. Let's say the 2 pictures in the left side and the middle, let's say that is your refrigerator. You're going to pull the refrigerator away from the wall. You're going to take that Ferrite suppressor, which opens up kind of clamshell in half, and you're going to clamp it back onto the power cord. You want to clamp it onto the power cord closer to the refrigerator than the end of the cord that goes into the wall. So snug it up closer to the appliance itself. And there are 20 of those Ferrite suppressors. So you do it to the refrigerator, and then you go find your deep freeze, and you do it to the deep freeze, and you go find your microwave, and you do it to your microwave, and you give one to your wife for her hair dryer, and so forth and so anything you want to protect, you put the Ferrite suppressor around the power cord. The picture in the lower right corner is the back of a PV panel. So for those, there are 40 of those. You want to come about 4 inches below the junction box there and clamp onto both wires. You want to clamp that Ferrite suppressor onto both wires on the back of the PV panel. And then we recommend putting a zip tie around that. A little bit of military redundancy there, but it is outdoor application. So, thermal expansion, hot, cold, hot, cold, hot, cold. We do recommend putting a zip tie on that. So again, you get 20 of the suppressors for the appliances in the home, 40 of the suppressors for the panels, and that's how they both get used. Rapid shutdown. Rapid shutdown is a combination of third-party devices and integration with the Sol-Ark inverter itself. The third-party devices are Tigo TS4 series is a popular example. AP smart devices from AP Systems, that's another popular example. Midnight Solar is a third popular example. And so what I mean by the integration is, again, these toggle switches right here with the 2 of them that are lifted up, those are the PV inputs. They go into our motherboard and our inverter. And then to the left of that is this pin out area. Well, in there, pins 11 and 12 are the normally open rapid shutdown relay. So if that relay gets tripped, that is how rapid shutdown physically and electrically happens in the inverter. And then adjacent in pins 15 and 16, we have an onboard 12-volt power supply for the rapid shutdown transmitter. So again, the total solution of rapid shutdown is a combination of third-party devices that are going to be used out on the array, and then integration back into Sol-Ark that's going to bring those signals back into the Sol-Ark and integrate with it. This is a quick wiring diagram example of that. Let me move that down here. As you can see out here on the arrays over on the right side, you have the Tigo TS4s that are mounted out on the array. You've got your inputs coming in here. Pins 11 and 12 are the normally open rapid shutdown relay. Pins 15 and 16 run the power to the transmitter. And the total solution here is manifested by that combination of third-party devices and integration in the Sol-Ark itself. So now we mentioned that the Sol-Ark is very, very versatile, and we mentioned that the Sol-Ark can say yes in a lot of different situations. So let's say you want to go after something a little bit bigger, right? You want to go after a 200 amp panel, or you want to back up some bigger stuff. Well, the good news is the Sol-Ark 12K is stackable. It can stack up to 8 units in a 120/240 volt context. So this is a wiring diagram. And again, this is in our manual along with the other wiring diagrams. I'm going to move this little text thing out of our way here, and I'll let Dustin kind of go over this for us. but this is in a 120 240 volt context, and it's using 2 Sol-Ark 12Ks.
And guys, just a quick, sorry, there was a quick question from Clayton. So just to confirm, Sol-Ark does not come with rapid shutdown integrated out of the box. That's correct.
It does not. It does require, like David was saying, a third-party source. So that could be either Tigo. I believe the other one.
We carry the APS, AP Smart.
The APS. AP Smart, yes. The same thing, as long as if you're using either one of those, it's perfectly fine. One note I did want to point out before diving into this diagram, but if you are using Rapid Shutdown or if you're using the optimization portions of Rapid Shutdown, just be sure that if you are using Tigo or a AP Smart Systems version, that it is powered separately from our 12-volt power supply in our unit. Just because it does exceed what the 12-volt power supply can support, and therefore can short circuit or damage the inverter itself at that point. So that's only really if you're using the optimization parts, which uses the CCA box and everything like that. If it's just normal rapid shutdown using their transmitters, it'll be perfectly fine. But yeah, without further ado, so we'll look at this 12240 double system setup. The main difference here, and the great thing about 12240 is the fact it is really just paralleled. So all the AC inputs are paralleled to each other, hence why you see a lot of AC combiners. In this case, we are showing a whole home backup with two systems. A lot of the times you can get away with a two system for a 200 amp service. But please keep in mind, obviously, the project dictates the number of units. If it is greater or if their usage is greater, then we do recommend doing some sort of critical loads panel. But really, just the only things different between a single and a double is the AC inputs are paralleled, and the battery bank itself is paralleled to both units. They will each have their own independent MPPTs, so you can land up to, in this case, 8 physical strings into the inverter itself. So it does give you a lot of capabilities for expansion and a lot of power in terms of DC. So yeah, that's basically two system setup.
Thank you, Dustin. So this is going to be very, very similar. However, we've switched service voltages now. So we are now in a 12208 volt 3-phase, and I'll let Dustin go through this, and then we'll expand a little bit on 208 volt 3-phase.
Absolutely. So really, again, obviously the main difference here is in a two system setup, it is an imbalanced 3-phase. So you do get all 3 phases in terms of output, but as you can see on the notes on the left, it is a 4.8, 6.2, and a 4.8. So it is what we call unbalanced in that sense. And then the biggest difference here is going to be the wiring. So as you can tell, obviously, whenever we go to 4-wire in terms of the 3-phase, because we do work with 12208 3-phase Y. Unfortunately, Delta is a little bit different. So if you do have projects using 3-phase Delta, please give us a call and we can kind of discuss maybe some possible solutions. But in this case, we'll focus on the 208Y connections. So really here, you'll notice that the master, both systems are labeled master. There is not a slave unit at this time unless you get passed into 6 systems. But here you'll have the L1 and L2. Those need to be very important and labeled correctly because we do need to make sure the internal wiring is consistent with the phasing that's coming from the utilities. So 3-phase is definitely an interesting kind of wiring setup for the system. So if you are in a 2-system setup and you have questions, please reach out. We can kind of go into more details. But really, it's just kind of making sure the hardest thing is really making sure everything's labeled and labeled correctly, and so that it travels up the line and making sure that it's not any phase imbalance or out of phase down the line. So if you have questions, give us a call.
Excellent. Thank you, Dustin. And I believe we're going to roll right into the next one, as Dustin just alluded to, which now we're using 3 Sol-Arks in the same service voltage.
Absolutely. So here it would be a balanced output. So obviously really it follows the same lines as the other diagram before. But really, if you take a hard look inside the user areas as far as the AC, you'll notice that where we are leading with A phase on master phase A, then it has to be leading the next phase. In this case, would be phase B. So it is precarious, or it is pretty interesting when it comes down to the wiring. So again, just making sure everything's labeled appropriately. Same kind of use of AC combiners going to a whole home backup. So really, we could dive into more details if it's a project specific, but it's just it gets kind of interesting whenever you're looking at internal wiring and keeping it consistent throughout the whole project in a 3-system setup.
Yeah, and sticking with the theme that the Sol-Ark inverter is very powerful and very capable and very versatile, let's talk about 208 volt for a minute. I've done a lot of commercial and industrial solar in my day, behind the meter, a lot of 208 volt, a lot of 480 volt, but this is 208 volt. The 208 volt commercial buildings that I like are banks, pharmacies, CVS pharmacy, Walgreens pharmacy kind of thing, gas stations, or smaller food marts. Not the really big ones. The really big ones are probably going to go up to 480 volt, but it's the smaller food marts. So let's look at a battery backup. Why would somebody want battery backup? If you're a pharmacy and the grid goes down, you have high value inventory that is thermally sensitive. You have to keep your medicine cold. If the medicine's not cold, it goes out of spec for more than 5 minutes. You have to throw it away. Highly regulated by the FDA, high value inventory that needs to be kept refrigerated. So as far as I'm concerned, every pharmacy in America, North America, every pharmacy in Canada and the United States needs battery backup. They're all going to be 208 volt 3-phase. They have a little TPO membrane roof up there with a couple of air conditioning units. You can fit, I don't know, anywhere from 30 to maybe 70 kilowatts of solar up there. That's great. You can hook up to 13 kilowatts per inverter. So when you get to, 6 inverters, 7 inverters, you're talking 70, 90 kilowatts of PV, no problem. And then when it comes to batteries, you can hook up as many batteries as you want. So let's say a pharmacy has 6 Sol-Ark 12Ks, 70 kilowatts of PV, and 10 Fortress E-Volts. Okay, 70 kilowatts of PV, 6 Sol-Arks, and 185 kilowatt hours of batteries. That's going to be a $250,000 to $350,000 system. Fair enough. They're going to get a long-year solution, long-term solution, backing them up, going green, and providing critical backup if the medicine goes down. That is perfectly doable, perfectly sellable. Same thing with the gas stations, same thing with the banks. Banks want the battery backup to preserve their data. The gas station might want to continue to be commerce capable. So if everybody on the street was down because the grid was down, but my gas station was lit up, my cash register's working, my pumps are pumping gas, well, yeah, not only am I going to make record sales that day, but I'm also going to be helping the community in the middle of a crisis if I'm able to service people and provide gasoline when nobody else can. So I love that application. And the Sol-Ark enables yes in so many situations. I'm on mute. So I'll let Dustin talk about this briefly for just a quick second. This is the table, and it has to do with stacking. The top part is 12240 volt. The bottom part is 12208 volt, and it increases the capacity. As you stack these units, everything increases in terms of its continuous power, the pass-through power, the peak power, et cetera.
Mm-hmm. So yeah, it just breaks down. If you're ever curious on kind of what your pass-through or what your peak power would be for a project and kind of what you're needing, this is a good table to kind of put in perspective, an idea of how many systems would be required to meet the demand. So it does break it down in a 120, 240, and a 120, 208. So just bear in mind when you are looking at the 208, obviously there's some little asterisks there, but the one is obviously 2 of the 3 phases. 2 systems does allow you to have 3-phase, but it is imbalanced in the sense of all 3 phases. And then 3 and on, really you have to do in multiples of 3 after that. So, 3, 6, and then 9 is the max total. So just keep that in mind if you're ever looking. There is some great information that'll provide this in the manual, so that will help you kind of help design the system.
Thank you, Dustin. One of my favorite applications for the 208 volt is like a pharmacy, a small pharmacy that would need to keep their medicine cold if the grid ever went down. Excellent application for 208 volt 3-phase. Again, you can stack up to 9 Sol-Arks, 81,000 continuous watts, 108,000 peak power. If you have 9 Sol-Arks, you could hook up 9 times 13, 117 kilowatts of PV directly into those 9 inverters, and you could hook up, I don't know, a dozen Fortress E-Vaults. That's going to get you over 200 kilowatt hours. So a very formidable system, very functional, very powerful, and really enables a lot of battery backup possibilities in commercial. So I mentioned before, let me kind of move that guy over here. I mentioned before that if you touch the battery, you open the detailed volts view. Well, the detailed volts view is this one right down here. It's down below the main screen. So if I touch the battery for a couple seconds, it's going to open the detailed volts view. And as you can see, it looks at the solar and then breaks it into the MPPTs, MPPT1, MPPT2, the total. It takes the grid and it breaks it into the legs, and you can see what's going on with the grid. It looks at the inverter, and again, you can look at the inverter and it ties kind of back to the 2 MPPTs. You've got information about the load, you've got information about the battery, a little bit of information about the generator, and some temperature information down in the bottom right corner. Dustin, you want to add anything about that? I know you guys use that detailed volts view quite a bit.
Absolutely. So that screen after tapping the battery icon is very important, at least if you are giving us a call with any kind of troubleshooting, or if you're just needing help kind of programming the system. One thing I did want to point out is if you are using our limited power to home feature, which does utilize the included CTs mentioned earlier, this is a screen that we would recommend using to kind of verify that the CTs are facing the right direction, they're on the right phase, and everything like that, and specifically under the grid column. So if you are calling in, this is a screen that we use quite often. It does give us a lot of great information. So it's a great screen to work from as well.
Thank you, Dustin. So I mentioned before there are 3 phases to setting up a Sol-Ark, right? You buy a Sol-Ark, you get it to your customer's house, you've got a design, you got a 1-line diagram, you're ready to go. Phase 1, mount the Sol-Ark onto the wall. Couldn't be easier. Phase 2, do your wiring. Now, if you're a homeowner, that could be a little intimidating. If you're an electrician, it's pretty straightforward. But there's the wiring portion. And then the third part is the setup. Now, the setup couldn't be easier. The button right here, the sprocket, is the settings button. So if you put your finger on that, it's going to open this menu over here to the right here. It's going to open this where it says system setup. There are 4 big green buttons. System alarms, we don't really have to worry about. If there is a system alarm, you hit this settings button, it opens this up, you put your finger on system alarms, and it opens this view down here, which will chronicle any alarm and tell you when it occurred, so you can kind of go back in to troubleshoot it. But really, we're going to worry about these 3 right here that say setup. So once we put our finger on that sprocket, we're going to open this view with these 4 buttons, and there's basic, battery, and grid. We do the basic setup, we do the battery setup, we do the grid setup. Super easy. So the battery setup is, the basic setup is this right here. You can see there are tabs across the top: display, time, advanced, factory reset, and parallel. Dustin, you maybe want to walk us through the basic setup. By the way, all of this is done with your finger, and when you manipulate a screen, you click OK with your finger. You go to the next screen, you enter stuff, and you click OK. So again, this is done inside, in the shade, hopefully, maybe air conditioning, I don't know. It depends on where you're mounting the Sol-Ark, but it's literally done with your fingertip.
Yeah, absolutely. So it is very, important to go through this information, especially for the time and date, because this is important for the monitoring platform itself. So you do want to make sure it's aligned with yours appropriately, because we do send it, directly from our location here in Texas, so it is in Central Time. So it is important. I mean, really, the only few screens that are very important here are going to be like the advanced screen if you are trying to do gen peak shaving or grid peak shaving. This is also has another way to do auto detect home limit sensors. So like I was mentioning earlier about the limited power to home, we do have a program that can help simplify that process. And then finally, the parallel tab. So if you are doing any type of multiple system setup, obviously this is the tab you can work from. So the factory reset tab, obviously that's more for us. We do have a lot of things that we use here to do checks and before we send them out the units. The only item here that I would look at is lock out all changes. So if you do have, some requirements or rules or, protocols that require the system to be locked down in terms of settings, you can do that remotely and at the system itself. So any prying eyes won't be able to, change anything they're not supposed to.
Awesome. Thank you, Dustin. So from there, we go to the battery setup. So again, if there's the three big green buttons: basic setup, battery setup, grid setup. So Dustin just walked us through the basic setup.
Yeah.
And here's the battery setup.
Yeah, so again, this is a very, very important tab. I mean, this is the one that probably 50% of the time you'll hear us going to, or at least going to check the settings on. So it does come preset with some settings that are actually preset for our batteries, the PCCs. So if you are using lithium batteries or lithium-based batteries, please, please, please make sure you do change any of these values to reflect the battery that you're using. Because we do not want to, obviously overcharge or do anything that the battery won't like, especially if the BMS can shut down in those instances. So pretty straightforward. Obviously, the battery capacity at the top on that very first tab will be the total amount of amp hours. Your max charge and discharge are typically determined by the battery manufacturer themselves, and then obviously by the number in parallel. TEMPCO, obviously important for lead acid type of batteries, not very big for lithium. And then you do move on into the charge discharge type of tab. So here you will be able to change the float absorption equalization. So if we do not have any communications where the BMS is giving us all this information, we do recommend changing these to reflect the batteries you're using. So it's very important. Obviously, lead acid batteries are a lot higher in terms of voltage than typical lithium batteries, obviously depending on the manufacturer. But this is very important just to prevent any damage. So on the left-hand side, though, you do have the settings for your grid charge and gen charge. So if you are able to charge from the grid, all you need to do is just put a check mark. Gen charge is important if you're trying to use the two-wire start feature. So the start percentage is at which point the SoC has to drop below that value for longer than 30 seconds, and then at that point, the two-wire start will activate. And then the amps is just the amount of amps that you're able to pull from the generator for charging. The voltage and percentage mode, I will like to point out, is dependent on which one you're using beforehand. So in the previous tab, on the BAT tab, you do have use battery percent charge, use battery V charged. In most cases, if you're in lithium mode, it will be in percent mode. So it's pretty straightforward because we are getting that information. But everything throughout the settings is very dependent. So if you do not have comms, voltage mode is the only thing that you'll be setting if that's selected. Percent, obviously, same thing. Discharge tab, again, very important to set appropriately for the batteries. You do have different discharge values for lead acid versus lithium. Just to kind of put an example, Simplify, one of our partners, I believe their cutoff is 51 volts, whereas some of our other ones, Fortress and some of the other lithium iron batteries that we have partnered with, they go down to like 47, 48 volts, and they're allowed for their BMS. So just keep that in mind as you're going through that. Especially if you're using a battery that does not have communications. Resistance efficiency, obviously pretty straightforward. You don't necessarily, have to change it unless they're requested by the manufacturer. And then Bms Error Stop. So this is a newer program or a newer feature that we've added, especially with the comms that we have with most batteries. So if there is any times that the BMS shuts off or the communication stops, it's not, this setting right here, you want to have it unchecked because we don't want the inverter to shut down in those events. So what will happen is it'll default to the percent modes selected into the settings. So I just want to point that out because obviously if you're working on comms or if it's not functioning appropriately, it really saves a lot of headache as the system won't turn off and turn on all the time. Moving on, like David was mentioning earlier, we do have the Smart Load tab. This is where you'll set all the settings for AC coupled, generator input, or if you are not using or if you're wanting to change the generator input into a load output. So there are some corresponding settings in there that do depend on which one you select. And then finally, the wind turbine tab is has actually been removed. So we're actually going to be using that for some later features. So the wind turbine tab will not be located on the screen itself, but this will be something similar to what we'll have in the future. So we'll just keep that in mind.
Thank you, Dustin. So there are a number of power modes. I mentioned before that if the Sol-Ark is connected to your home and you've got solar photovoltaic connected to the Sol-Ark, you've got batteries connected to the Sol-Ark, perhaps you have a generator connected to the Sol-Ark. The Sol-Ark has a number of pre-programmed modes that will interact with the grid or not interact with the grid, depending on how you want to set it up, and save you money or make you money. So Dustin, would you walk us through this one, please?
Absolutely. So there are very much big differences between each mode, and definitely want to make sure it applies to the project you're working on. So for instance, the first one that you'll see selected is going to be grid cell. So if it is just a standard net metering kind of project, then really having that set, it's going to produce as much power on the sun off the panels and send it back to the grid, and anything used by the time it makes it to the utility will be consumed, and then the leftovers will be sold back. There is a limited power to home feature. So this is for self-consumption for the whole home or for the whole project is how I would like to look at it. Because what it uses is the external CTs that come with the inverter, and those go in between the main service panel and the utility meter, or just where the utility is coming in from. So what it does is it allows us to receive information for the amount of loads or the amount of power that the main service panel is using, and it allows us to offset those loads with solar or battery if you decide to use so. So this is a very big important one, and you can use it in conjunction with grid cells. So for instance, if you wanted to offset the loads with solar and only use the batteries to offset your main service panel loads and not sell back, then you can use a conjunction of limited power to home and grid cell with what we call time of use, and I'll kind of break that down in a little bit. But what that allows you to do is it allows the customer to really take advantage of their full solar throughout the entire day, and then also use the batteries at night to really take advantage of the savings without pulling power from the grid.
Thank you, Dustin.
The next one is going to be limited power to load. Limited power to load is going to be directly just whatever's connected to the load breaker of the system. This will be mainly for your off-grid. So if you are off-grid, this is the mode you would select, obviously, because we don't have a difference in a main service panel or a utility to sell back to. And then finally, we do have time of use. So time of use is a big one, and a one that we do see used quite often. So this does allow you to prioritize or at least set different timestamps to discharge the batteries during specific hours. So for instance, if you have peak hours or peak demand hours, then you can set a certain amount of the batteries to be used to prevent that peak from happening or to prevent from using the grid power even at nighttime. So very customizable, very helpful for people that want to take advantage and don't mind using a little bit of their battery every day to help savings.
Awesome. Thank you, Dustin. So this was a segue into the third part of the setup. So as we mentioned in the setup, let me back up here real quick. As we mentioned in the setup, you've got the three green buttons: basic setup, battery setup, and grid setup. We went through the basic setup, went through the battery setup, talked about the power modes, which is now the grid setup. So this is the third part of the setup of the Sol-Ark. It's the grid setup. There's a number of tabs here. I'll let Dustin kind of carry on with it. But as you can see in the first tab, this is where you select these power modes.
Absolutely. And so just like I went over, each individual one, you can use them in conjunction with one another. So in this example, we have a grid cell and a time of use. And specifically, you can actually set different times to even sell power back from the battery. So as you'll see on the right-hand side, once time of use is selected, you'll have this giant chart, which you'll be able to change the times, the amount of power, and then the battery. The battery stands for the SOC. So it's however much you want left in the battery. And then you have the two columns for charge and sell. So very helpful in terms of being able to fine tune really what you're trying to do for the project. And then moving on, the cell control tab and the grid parameters tab, those are really important for if you're trying to select your 120/240 or 208 3-phase 50/60 hertz. You have your grid hertz high, your grid hertz low. Those are typically pre-selected by UL 1741 SA. But you can adjust those if you select general standard. So those are what we typically use for off-grid. So very customizable in the sense of whatever project you're trying to do. If you ever have any questions, or if you're ever curious on, what mode works best, or if you ever have, especially for generator connections, we can widen the frequencies to be a little bit more forgiving. Just give us a call and we can kind of point you in the right direction and help you, get it set appropriately for what settings you're needing.
Thank you, Dustin. Last thing I would add to this is just that right here under time of use is this button that says setup, and that opens up this screen down here. People that have a time of use rate structure, sometimes it's 7 days a week where literally the utility says, hey, we've got this time of use rate structure, and it applies universally 7 days a week. Other times they say it's Monday through Friday. So depending on your customer's utility, exactly where they're at, you can customize this time of use by the days right here, hitting that button that says setup. Awesome. Thank you, Dustin. So the second part of this, Dustin, I know this is going to be pretty quick, but if you would just give us a little bit of color as to these screens.
Yep. Absolutely. So again, these are very important if you're just trying to do something specific. So we do have the ride-through frequencies and ride-through voltages for, if certain grids require them. These are the sections where you would set those. Power factor and the relay tabs are actually very rarely used, but I mean, if you're really, the power factor tab is if you're AC coupling, and then the relay tab, that is going to be for later use down the road. We don't necessarily use that currently, so just keep those in mind as they are located here once we release some information.
Thank you, Dustin. So time of use and peak shaving modes. I know Dustin had briefly talked about this. I would just add that when the time of use, again, this setup button right here is going to open up these days of the week so you can customize it for your customer's exact rate structure, whatever utility they're in and however they manage that. Same thing right here with these time slots. There are 6 different time slots. You can enter this information. My utility on the Western Canada does this, bing, 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 bing. My utility in the middle of Canada does this. My utility in Eastern Canada does something else. You can enter all that information here. And this is where, and I'll let Dustin elaborate on this a little bit. You can set the wattage right here with the power. You can set the voltage, and then the charge in the cell you can select. So right here in this time of use, 9 to 1, 1 to 5, they're selling in here. So this is their time of use rate structure. It's obviously 7 days a week. And they're telling their Sol-Ark to, sell the power, excess power to the grid, basically between 9 and 5. Anything you would add, Dustin?
Nope, you hit it right on the hammer, right there.
Awesome, thank you, sir. Let's see, smart load. I'll let Dustin talk about this. It's a great feature.
So the Smart Load tab does allow you to use the generator breaker as a load output. So it does allow mainly people using this off-grid for taking advantage of additional solar production. So if your loads are being met, but you're able to produce an additional amount, you can turn on the smart load, or the system will turn on the smart load, which will allow you to take advantage of some additional loads connected to the generator breaker to really take advantage of any extra solar use as your main loads or your batteries are already fully charged. So very customizable.
Yep, thank you, Dustin. And the smart load is great. A lot of people use it either with an air conditioner or perhaps a hot water heater. And as Dustin mentioned, it just, I've got extra production. My PV my loads are being met and I'm off grid. So what am I going to do with it? Oh, let's turn on that 60-gallon water heater and make sure that water's hot so I can take a hot shower later. It's a great function. So commissioning the Sol-Ark, very, very simple. Let me move this guy over here. So right here, the last page in the 12K manual is our warranty. The second to last page in the 12K manual is this right here. And this is an installation operational verification checklist. It's got 14 questions on it right here, and they're all yes or no questions. I did have a dialogue with an installer the other day. If some of these questions do not apply to your particular install, just skip it or scratch through the YN at the end and put NA. But the spirit of this form is to remind you of all the little things to do for a nice, good quality installation. It asks you if the battery lugs have been tightened. It asks you if you mounted it outdoors to where the LCD screen is protected from the sun. That's one thing that we ask that you don't do, is if you are mounting the Sol-Ark outdoors, is not to mount the screen in direct sunlight if possible. So the operational checklist, again, the installer would go through the checklist, answer each of the questions. They would put their name, their date, they would sign the form and then give it to the homeowner. The homeowner would look at it, put their name, put their signature and date it, and it gets turned in with the paperwork to register the Sol-Ark inverter and enact the warranty. So that's what that's for. It's the second to last page in the manual. It's included in everything we ship. So PowerView is what we call our monitoring solution. Just to call it a monitoring solution is kind of a slight. I mean, that's kind of an insult to it. PowerView provides you access. It provides you visibility. It provides you a great degree of granularity where you can say, I want to see what the battery's doing. I want to see what the PV's doing. I want to see what the inverter's doing. I want to see what the grid's doing. Maybe I want to see what that generator's doing. PowerView enables you to kind of slice it and dice it, if you will. And a PowerView also provides complete remote control. All of the settings that you just witnessed as we went through the basic setup, as we went through the battery setup, and as we went through the grid setup, all of this is available to you in PowerView. This is PowerView right here. I want to just going to start the video or not. There we go. So this is kind of a visual look at PowerView. Again, it'll tell you what the PV's doing. It'll tell you what the battery's doing. It'll tell you what the load's doing. It'll tell you what the grid's doing. The Sol-Ark's in the middle. Dustin, do you want to maybe kind of give us a little bit of overview of PowerView? You probably do a much better job than I will.
Yeah, so it's a really great PowerView, and I mean it gives you a lot of great information. There's a lot of great diagrams, or not necessarily diagrams, but graphs that it'll pull for the information as the system is performing. So definitely give us a call, or we can go through this. We actually have some really great information on our YouTube channel that dives into all the different details because there's a lot to go into, and I know I think we're a little bit pressed for time, but it does have a lot of great information if you want to see how it's performing, or you can even change settings remotely through this platform. And then also on top of that, there is fleet monitoring. So as an installer, if you want to kind of keep track of all your systems, kind of see a brief overview of what they're doing, how they're performing, this really does provide a really great solution to give you that information at your fingertips.
Awesome. Thank you, Dustin. And the coolest thing about PowerView, in addition to its really, really solid functionality, PowerView is free. It's free for the homeowner. It's free for the installer. It's free for life. We won't ever ask you for a subscription. You will have complete access and visibility to your system for life. And let's see. I think with that, where do you buy Sol-Ark inverters? That is a very simple answer. You buy all your Sol-Ark inverters from BayWa. With that, a little bit of takeaways. In the interest of time, I'm going to bang through this real fast. Our inverter is versatile. It's very simple. It's very flexible. It's fast and lean. You can see these bullets here. We have a 4 millisecond transfer time. We have the best in round trip efficiency in the business. We're smart. You can fly the Sol-Ark with an Android. You can fly it with an iPhone. You can fly it with a tablet. You can fly it with a laptop. You can fly it with a PC. We're long lasting. We're compliant. We have lots and lots of certifications. We stay current with regional programs like Connected Solutions. We stay current with IEEE, Open ADR, BPP functionality, etc. We have great customer support. We literally answer our phone 7 days a week, live in person, and we are pre-approved from all of these different lenders' financial packages as far as Sol-Ark goes. And our phone number is right here, 972-575-8875. Please call that anytime. We are 100% here for you. We got a great new website, Sol-Ark.com, SOL-ARK.com. Check that out. Lots of good information there. And we do have, as Dustin just mentioned, a YouTube channel where we do, 3 to 5 minute videos on different topics and kind of post them up there to try and be as useful as we can and proactive as we can. We've had more than one installer standing there with their phone, watching the YouTube channel, finishing their installation, going, God, I love you guys. So that's great. Sometimes they call us too. We FaceTime them. We do all kinds of stuff. So give us a shout. We will we do two things well right here. We do best-in-class technology and world-class customer support. A lot of this presentation was about our best-in-class technology. If you give us a call, send us an email, we will show you and prove to you our world-class customer support. And I would add that we are going to continue to innovate. We have several new products that we're going to be launching between now and Christmas. I wish I could disclose more to you at this time, but Dustin would have to kill me. So we have new products coming. It's going to be an exciting second half of the year for Sol-Ark. So with that, major shout out to BayWa. Thank you very much for organizing this. Thank you to everybody who's listening. Thank you for your participation. Thank you for your support. And thank you very much for your time today. But that's it for us. But thank you very much.
Thanks, David, Dustin. Really appreciate you guys taking the time to educate us on the product. Just a couple of notes. We do have stock on the product across Canada in our warehouses. If you have any additional questions, just reach out to your sales reps. We did record this presentation, so ask your rep if you'd like an advance copy. Otherwise, it'll be released during the monthly newsletter. Thanks again for everybody for attending. We really appreciate your time and hope everyone's taken care of there. Have a good day.
Absolutely. Yeah.
Excellent. Yeah, thank you very much. Big shout out to BayWa. Love you guys.